Okay, let's talk about something that sounds maybe a bit wild at first glance. What if the absolutely absurd, often hilarious ways people break video games for fun? What if that actually tells us something really important about the powerful AI tools now building software?
It does sound counterintuitive, doesn't it? But
Yeah,
there really is a fascinating thread connecting them.
right. So this deep dive is all about pulling on that exact thread. We're exploring these, well, surprising parallels between that quirky subculture of humorous game exploits and the explosive rise of agentic AI in software development.
Yeah, and we've been digging through quite a few reports and, community discussions sitting right at this very specific, very interesting intersection.
And our mission today is basically to guide you through this world. We'll start with the playful side, the sort of system hacking in games.
Figuring out how to make a system do things it was never meant to do.
Exactly. And see what insights that gives us about our changing relationship with complex digital systems, AI included.
It really has a lot to say about the future of creative work, especially in software. We've tried to distill the key ideas from the material right here for you.
Okay, so let's dive head first into that delightful chaos of deliberately broken games.
Hmm.
There's this whole corner of YouTube, right? Creators like The Spiffing Brit and Let's Game It Out. They've built huge followings just by pushing game mechanics way past their breaking point,
Yeah.
often just for the laughs.
Absolutely. The Spiffing Brit is a prime example. He has this wonderfully dry, satirical British persona, and his whole thing, his shtick, is finding these game-breaking exploits. His catchphrase, perfectly balanced game with no exploits, is just dripping with irony as he shows something completely unbalanced.
It's comedy gold. I
Yeah.
mean, he's famous for conquering the massive world of Skyrim armed with, like, nothing but a humble fork.
Right.
Or in a game like Two Point Campus, manipulating the economy for infinite money, often finding things like integer overflows.
Yeah, where a number gets so huge the system can't handle it, flips negative, and suddenly you have billions. It's absurd.
He even made simple battering rams in Age of Empires 2 travel at something crazy, like 800 miles per hour.
And then you've got Let's Game Out, who has a different but equally entertaining style. He
Yeah.
actually describes his process as torturing software.
Torturing software, I like that.
Yeah, really pushing simulation games to their absolute limits, using extreme micromanagement or just provoking glitches. The goal is often just to see some astronomical result, millions of units, resources, whatever, or, just to make the game crash spectacularly.
He'll spend hours grinding for millions of in-game currency just for the show, basically. Not because he actually needs it to win.
Exactly, it's pure spectacle.
And there are tons of other examples too. Legend of Total War, finding ways to break strategy games, Budget Monk doing similar things in games like Europa Universalis The Thief.
Yeah.
Age of Empires 2 has those famous glitches like units moonwalking, right?
Yeah.
And StarCraft 2 players have developed these incredibly intricate micromanagement techniques.
With basic worker units even. Like the manor pylon, using a cheap building just to block an opponent's entrance. It's tiny but effective.
Or drone drilling, that repetitive action
Yeah.
to gain a tiny early advantage that can just snowball.
And what's truly fascinating about these isn't just the result, it's the nature of the exploits. They often don't rely on conventional, skilled gameplay.
Right?
Instead, they come from pushing the system far beyond its intended rules, or using highly repetitive, sometimes kind of counterintuitive actions.
That intense micromanagement.
Exactly. Intense micromanagement to get these massively disproportionate, often game-breaking outcomes.
And the humor is absolutely central to it all. It's the absurdity, isn't it? Seeing 86 billion people dying per month in a simulation like Stellaris because of some tiny tweak.
Or just the pure glee of clearly subverting the developer's careful design. There's this feeling of gaining immense, almost godlike power over the digital world.
Yeah, it taps into something interesting. Some sources call it the humor of overwhelm.
Right, where the comedy comes from seeing systems operate at scales or in ways that feel beyond normal human comprehension or control. It's like both hilarious and slightly unnerving at the same time.
So what's the real appeal here beyond just getting an unfair advantage? I mean, it's definitely that joy of transgression, right?
Yeah.
A playful rebellion against the rules.
For sure. But it's also incredibly creative. You have to kind of reverse engineer the system in your head, use lateral thinking to figure out how the pieces fit together in a way no one intended.
It's like solving a puzzle the creators didn't even know they made.
Precisely. It's why content creators use terms like instructional, funny, entertaining. You're actually learning something about how the game engine works while being entertained.
And that micromanagement element, it keeps showing up, doesn't it?
It really does. Many of the most powerful exploits require engaging in these, frankly, tedious, intricate micro actions to unlock that disproportionate power. It highlights a willingness to endure, or at least appreciate, that level of granular control for a massive payoff.
Like the spiffing Brit managing those huge populations in Stellaris. What was it, the synaptic lathe?
Yeah, the synaptic lathe, exactly. Managing countless tiny elements just for one big research breakthrough. It requires immense focus on the small stuff.
Okay, now let's pivot. Let's go to the other side of our equation here. While people are having a laugh-breaking games, there's this far more serious, potentially world-changing transformation happening in software development with agentic AI.
Exactly. And this is different from the generative AI we hear so much about, the stuff creating text or images.
Okay.
Agentic AI is designed to understand a high-level goal, make its own decisions on how to achieve it, and then take autonomous actions, executing a sequence of tasks to solve a problem.
So it's not just generating, it's doing.
It's doing. It's an evolution towards AI that functions much more like an independent partner or agent.
And these aren't just theoretical anymore, right? They're actually being used.
Oh, yeah. OpenAI Codex, which powers a lot of the coding capabilities in ChatGPT, is built on large models designed specifically for software engineering. It can do things like generate code from just a plain English description, find and fix bugs, rewrite code to be cleaner, what developers call refactoring, and write small tests, unit tests, to check if code works.
And it hooks into the tools developers already use.
Mm-hmm. It integrates directly into development workflows via platforms like GitHub. It can help review suggested code changes, pull requests, write summary notes about changes, commit messages, summarize differences between versions.
So automating the boring stuff.
Pretty much. It can even automate merging changes if a human approves it. It's built to handle those repetitive tasks that eat up developer time. Developers can even guide its behavior using special files like agents SMD.
But it's not perfect, I assume.
No, definitely not. Like any new tech, it has quirks. It can sometimes hallucinate make-up code that doesn't exist or isn't right, and it can struggle with understanding really large, complex code bases.
And Google's working on something similar, Jules.
Right. Google's developing Jules. They describe it as an asynchronous agentic coding assistant. It's powered by their Gemini model and aims for a more independent partnership with the developer.
Asynchronous, meaning it works in the background.
Yeah, basically. Jules is designed to clone an entire project's code onto a secure virtual machine so it gets the full context. It can write tests, build features, fix bugs, manage dependencies. It even offers audio change logs, which is interesting.
Does it explain itself? That seems important.
That's a key point Google highlights. It apparently presents its plan and reasoning before making changes, which is a good transparency feature. And yeah, being asynchronous means you give it a task, and it works on it while you do something else.
Still early days for Jules, too, though.
Oh yeah, it's in beta. Early users have mentioned it can be slow sometimes or occasionally hallucinate its progress reports claiming it's finished something when it hasn't quite. Needs refinement.
So the intended utility for both of these is pretty massive, then.
Absolutely immense. These tools aim to drastically streamline software engineering, automate the tedious stuff, speed up development cycles, maybe even improve code quality through consistency. The goal is really to free up human developers to focus on the higher level work. Innovation, architectural design, understanding complex problems using those unique human skills AI can't replicate yet.
Okay, here's where it gets really interesting. Let's start explicitly drawing these parallels.
Yeah.
How does that culture of, funny game exploits actually give us insight into this serious world of AI-driven software development?
Well, what's fascinating is looking at the creative aspect first. Discovering a game exploit requires this kind of lateral thinking, right?
Yeah.
Using a system in a way it wasn't designed for. It's an unexpected creative act.
Yeah.
And crafting an effective prompt for an agentic AI that's becoming a new creative form in itself. You're guiding this incredibly powerful system, using abstract language to achieve complex, sometimes novel solutions or complete multi-step tasks.
So both share that kind of aha moment,
Yeah.
figuring out how to unlock the system's potential or maybe its vulnerability.
Exactly, that feeling of realization of, oh, I can make it do this.
And thinking about utility,
Right.
how that gets redefined.
Mm.
Game exploits make niche or even useless things incredibly powerful, like the Skyrim fork example.
Right.
Agentic AI seems to do something similar for coding tasks that were maybe just impractical or mind-numbingly tedious before.
Totally. Imagine rewriting a million lines of old code, a massive refactoring job. or generating comprehensive test coverage for a huge project. These are things that were often too costly or time-consuming to ever do properly. AI suddenly makes them potentially feasible.
So it changes the effort versus reward calculation.
Fundamentally, game exploits often yield these disproportionate returns minimal input, like a weird mouse click sequence, for infinite gold or invincible units. AI tools offer the potential for exponential productivity gains. We're seeing reports, developers completing tasks maybe 55% faster, or anecdotes of tasks that might take a week manually being done in, I don't know, half a day by an AI agent.
That's a huge shift.
It is. It taps directly into that human drive towards the path of least resistance, finding the most efficient way.
And that intense micromanagement we talked about in games. The humorous exploits often require performing these intricate, repetitive, really granular actions to unlock massive power, like that StarCraft II drone drilling.
Right. And agentic AI is, in a way, the ultimate micromanager. It can execute a vast number of tiny microcommands, writing lines of code, checking dependencies, running tests flawlessly, and at lightning speed.
All based on a single high-level human instruction.
Exactly. The human developer shifts from doing those tedious microactions themselves to defining the overarching strategy and just delegating the execution burden to the AI.
That Stellaris synaptic lathe example you mentioned. Managing a huge, complex system for a single breakthrough. It really does feel like a developer directing an AI agent to process vast amounts of code or data.
It's a surprisingly good analogy, yeah.
And both also involve operating right at the edges of a system's defined parameters, don't they?
They do. Game exploits push the game's rules to failure or absurdity, often for that comedic effect, the perfectly balanced irony. AI, while aiming for correct solutions, can also generate unexpected or novel code that might challenge existing ways of doing things. Or, it might hallucinate incorrect code because it's operating at the edge of its training data, pushing boundaries intentionally or not.
And finally, this idea of emergent behavior.
Yeah, that's crucial. Game exploits are often surprising, emergent behaviors that arise from complex interactions within the game engine. Nobody planned for the fork to be that powerful. AI systems also have the potential for unforeseen emergent behaviors, sometimes positive, like finding a clever solution, sometimes negative, like introducing a subtle bug. Exploring game exploits, which involves experimentation and pushing boundaries in a really low-stakes environment, it kind of offers a practice run for navigating the unpredictability that can come with powerful AI.
So it highlights why vigilance and testing are so critical with AI, because the stakes are way higher.
Much, much higher. Robust testing, adaptability, careful oversight become absolutely paramount when unexpected behavior could have real-world consequences.
Okay, so let's bring in the people. What are the actual humans in these communities, gamers and developers, saying and feeling about these phenomena?
Well, in the gaming community, views on exploits are pretty varied, as you might expect. If it's a single-player game, they're often seen as fun, clever, maybe even a creative way to experience the game differently.
Like, yeah, it's broken, but it's fun broken.
Exactly. I saw a comment like, sloppy but damn those exploits fire, capturing that mix of imperfection and effectiveness. It becomes a way to overcome challenges or just mess around.
But shift to multiplayer.
Whole different story. Exploits are almost universally condemned as cheating or unfair because they disrupt the competitive balance for everyone else, breaks the social contract of the game.
Makes sense. And what about micromanagement in games?
Also divisive. For some players, it's just tedious. The downfall of certain game genres, especially if it feels like, tedious micro without benefit, like shuffling units around pointlessly for hours.
Get that.
But for others, it is the game. It's the core of strategic depth. They find it genuinely engaging when it's fun, micro with benefit, when those detailed actions lead to real tactical advantages.
Okay, now over to the developer community. How are they reacting to these powerful AI tools?
It's a really fascinating mix of excitement and, frankly, apprehension. Some developers admit it almost feels like cheating.
Cheating? How so?
Like they're bypassing the years they spent mastering complex coding skills manually. Creates this kind of cognitive dissonance. You hear terms like vibe coding, just relying on the AI's output without fully understanding the code underneath.
Or like God mode.
Yeah, God mode, or faster than thought phrases that capture that feeling of sudden immense power from AI assistance.
But there's excitement too.
Oh, massive excitement about the potential productivity gains. Developers talk about AI saving them literally a day of writing routine unit tests or feeling like they have an ant farm of AI agents working for them. The general feeling is AI is great for handling grunt work, freeing them up for, more interesting stuff.
But that's balanced by fear.
Definitely. There's a real fear of skill atrophy, the worry about forgetting how to code the fundamentals if you rely on AI too much. Also, concerns about code duplication if everyone's using AI to generate similar solutions without much thought.
And the big one, jobs.
And of course, the long-term fear of job displacement. That hangs over a lot of these discussions.
So developers see the power, but also the risks.
Exactly. They see these tools as absurdly powerful and a potential game changer for automating routine code, fixing bugs, even learning new languages or frameworks. But they're also very clear about the limitations. AI often struggles with truly novel or complex problems, and it absolutely requires significant human oversight.
Because of the hallucinations.
Yes, because they can hallucinate or produce code that's subtly wrong or maybe insecure. So, skillful prompting to guide the AI effectively, and then careful human review of the output. Those are seen as absolutely critical skills now.
Okay, so if we connect these community views, it sounds like both AI tools and game exploits are seen as these powerful leverage points, these power tools.
That's a good way to put it. This power can be incredibly empowering, doing much more with less effort, but it also comes with risks, including that concern about de-skilling if people over-rely on the tool without understanding the underlying mechanics.
So trust but verify applies to both.
Absolutely, it really reinforces that principle. Whether it's code generated by an AI or an unexpected game mechanic you've discovered, you need to test it, understand what's actually happening, and verify it works as expected.
AI is an aid, not a replacement.
Right. It's seen as an aid, a tool to enhance human capability, not replace it entirely. And it also highlights what you might call the democratization of overwhelm.
Democratization of overwhelm.
Yeah, how game exploits can create these comically large numbers and simulations. That kind of mirrors AI's ability to handle or generate overwhelming amounts of data and code. The human role then shifts from doing that overwhelming micro work to curating, guiding, and making strategic decisions based on the AI's massive output.
So as we wrap up this deep dive then,
Mm.
it's really fascinating to see how this journey from breaking games for laughs all the way to serious AI development reveals this consistent pattern. Human ingenuity interacting with complex systems.
Absolutely. The parallels, we talked about how creativity adapts, how utility gets redefined, that dramatic shift in effort versus reward, and the ultimate delegation of micromanagement. They really highlight some pretty profound shifts happening.
It really emphasizes this evolving relationship we have with our digital tools, doesn't it?
It does. The shift is away from direct, granular control, writing every single line of code, moving every single unit towards a higher level of strategic direction. The human defines the goal, sets the intention, and the system, whether it's an exploited game engine or an AI agent, figures out and executes the steps.
And this abstraction of labor makes that trust but verify idea absolutely paramount.
More important than ever, yeah.
So this raises a key question about what the most valuable skills are actually becoming. It seems like it's shifting towards this kind of meta skill.
What do you mean by metaskill?
Like the ability to deeply understand a complex system, whether it's game mechanics or an AI's capabilities, its limitations, its biases, and then skillfully guide it to achieve desired outcomes, maybe even unexpected emergent ones.
Ah, I see. So analytical thinking, strategic planning, adaptive problem solving, those become more central than just the raw technical execution.
Exactly. It's about orchestrating the system.
However, it's crucial to remember the stakes. While game exploits offer these valuable kind of lower stakes lessons in system interaction, the stakes with AI are exponentially higher.
Right. Breaking a game for fun has minimal consequences, usually.
Exactly, but breaking a software pipeline or deploying AI code that has unintended flaws, that can have serious real-world economic consequences, security risks, even societal repercussions.
So caution, rigorous validation, ethical foresight,
Mhm.
they're non-negotiable with AI.
Absolutely non-negotiable.
Okay, so here's something for you, the listener, to think about as you go forward. This shift we've discussed towards guiding powerful systems rather than performing every microstep ourselves. It's fundamentally changing what we value in both work and creativity. Are we becoming more effective orchestrators of complexity? Or maybe do we risk losing touch with fundamental skills in the process? What does this evolution mean for your own learning, your own work in the future?